Hello everyone, my name is Priyank Saxena. Today in this lecture we will see periodic classification. Periodic classification is a big chapter. Now in this we will see some one or two properties, okay, how they vary in a group, how they vary in a period. Now what happens up here, the next thing, first thing is variation of size in a period. Variation of size in a period. Here see, size means we are talking of a radius. Radius in a period. Now what happens up here, when we are talking of a variation of a size in a period, we have a lithium, then beryllium, then boron, then carbon, nitrogen, another thing. Clear? Now what happens up here, see, if you talk of lithium, how many number of electrons and protons this lithium is having? It is having up atomic number 3 and the mass number is 7. Here the atomic number, we will write only atomic number is 4, here atomic number is 5, here atomic number 6, here atomic number 7, here atomic number 8, here atomic number 9. Clear? Now what happens up here in this case, see, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine is there. Now lithium, here we are having up a 3 protons. We are having up a 3 protons. With this, we are also having up a shell number 1, 2 electrons, shell number 2, 1 electron. So, if I will draw up the electrons here, shell number 1, 2 electrons, shell number 2, 1 electron. While we go for a beryllium, when we go for a beryllium over here, this beryllium is having up a, I will draw only 2 elements. Okay. Now, beryllium is having up a, here, beryllium is having up a 4 protons, shell number 1, 2 electrons, shell number 2, it is having up a 2 more electrons. Now see, when you go from, see, if I write up the means, I cannot draw exactly the all the electronic configuration in this shell format. What I can do here, see here, this is having up a 2 and 1, the atomic number, here it is 2 and 2, here it is 2 and 3, here it is 2 and 4, here it is 2 and 5, here it is 2 and 6, here it is 2 and 7. Okay. Now what happens up here in this case, 2 and 7 is there. See, every of this case we are having up a 2 shells. We are having up a 2 shells means the size, the outermost size will always be same for this lithium. This is lithium, this is beryllium, this is boron, this is carbon. Everywhere the outermost shell will have a almost same size. It will have a almost same size. Now what happens up here, the next thing, this is beryllium, but one thing is increasing. What is increasing here? If I'll talk of lithium, I have a 3 protons. If I'll talk of beryllium, I have a 4 proton. If I'll talk of boron, I have a 5 proton. If I'll talk of carbon, we have a 6 protons. My number of protons are increasing in the nucleus. When my number of protons are increasing in the nucleus, here what will happen up in this case, see what will happen up here, this is positively charged, protons are positively charged, protons are positively charged, while electrons are negatively charged. Electrons are negatively charged. Now what happens up here in this case, see, there is a positive charge, there is a negative charge. Okay, this positive charge will attract up the negative charge towards its side. So what will happen? The size of an atom will always shrink because of a attractive force. Because we are having up a attractive force between a nucleus and the electron, the size of the atom will always shrink. Because the size of the atom will always shrink here, so see how it will shrink. Here it is attracting up the last electron, here also attracting up the last electron, here also attracting up the last electron, here also attracting up the last electron. But when you move from lithium towards fluorine, from lithium to fluorine, the number of protons are increasing. Number of protons are increasing. What will happen? The attractive force will increase. Number of protons are increasing. Attractive force will increase. Attractive force will increase. So what will happen? See, moving left to right. Moving, this arrow means moving left to right. Moving left to right, here the number of protons increases. Number of protons increases. What will happen? Here nuclear charge will increase. Nuclear positive charge will increase. Nuclear positive charge will increase. Attractive force of attraction will increase. Force of attraction between there is a force of attraction between the nucleus and the last electron. This is F attractive. This is also F attractive. This will increase. When attractive force will increase, what will happen? See, protons are increasing, attractive force is increasing. Attractive force is increasing, the size will decrease. So what will happen? The size or the radius will decrease. This is how the size will vary in a period. Okay, you take any example like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, moving left to right, size will always decrease. By protons will increase, it means nuclear charge is increasing. Nuclear charge is increasing, it means the force of attraction will be increasing. The size will always be decreasing. Clear? Now we'll move to the next slide. Now see what will happen up in this case. In case of a group, see, hydrogen is having upper atomic number. Hydrogen is having upper atomic number 1. Lithium is having upper atomic number 3. Sodium is having upper atomic number 11. Potassium is having upper atomic number 19. This rubidium is having upper atomic number 37. Cesium is having upper atomic number 55. The shells will keep on increasing. Here the atomic electronic configuration is 1. Here it is 2 and 1. Here it is 2, 8 and 1. Here it is 2, 8, 8, 1. Clear? So here number of shells are 1. Here the number of shells are 2. Here the number of shells are 3. Here the number of shells are 4. Here the number of shells will be 5. Here the number of shells will be 6. Moving down a group, okay, the number of shells in atoms will keep on increasing. When the number of shells will keep on increasing like this, what will happen? The size will automatically increase. Now here also we can ask up a question that why not here also protons are increasing. They will also attract up the electron with a higher force. Here also this is protons which are increasing. So here also they will attract up the last shell. Here also they will attract up the last shell over here. Okay, but what will happen? This will see protons will attract with some force, but with that the case of this increase in the shells will outweigh the force of attraction. Means force of attraction will be there. Yes, this will try to decrease the size, but because of shells the size will increase more but decrease less. So the overall size will always increase. So in a group the size will always increase in a group. There are certain exceptions in group 13 of aluminum and gallium, but that is something else called as a screening effect. Here generally moving down a group, size always increases. Is it clear? Now we will come to the next slide. Next is ionization enthalpy. Ionization enthalpy is, what is ionization enthalpy? It is the amount of energy given to any gaseous isolated atom. Gaseous means it should be in a gaseous form. Isolated means it should be isolated from whole world, means it should not have any force of attraction. It should not have any, this is nucleus, it should not have any force of attraction from somewhere. Clear? So what will happen here? It should be gaseous isolated. There should be no atom nearby. There should be no atom. If there is one atom nearby, no, then we will not consider this one. Okay, gaseous isolated, there should be nothing nearby, isolated atom. Now there is a valence shell electron over here. This valence shell electron we want to take out of the system. This gaseous electron we want to take out of the system. Okay, to take out this valence electron we have to give up, this electron we are taking up, we have to give up a certain energy. And this energy is called as a ionization enthalpy. Clear? Now see, how does it vary in a period? We know that just now we have discussed, for example, here moving left to right, what happens up here? See, now here size decreases. size decreases, so force of attraction increases. Force of attraction increases, so what will happen? Moving left to right, size decreases, force of attraction increases. Force of attraction increases, it means it is tough to take out electron. It is very tough to take out electron. Because it's very tough to take out electron, your ionization enthalpy will increase. So moving left to right, the ionization enthalpy will always increase. But here there is one exception. One exception is there. That exception will come in case of a magnesium and aluminium. That exception will come in case of a phosphorus and sulfur. What will happen up over here? See, magnesium, we are having up atomic number 12. If we write up our electronic configuration, it is 1s2, 2s2, 2p6, 3s2. If you write up electronic configuration of aluminium, it is 13, 1s2, 2s2, 2p6, 3s2, 3p1. Clear? Now what happens up? See, your magnesium is having up a complete subshell. While your aluminium is having up a incomplete subshell, or partially filled subshell, complete subshell. Clear? And this is having up a incomplete subshell. Because it is having up a complete subshell, it will be more stable. Because of more stability, because your magnesium is having up a complete subshell, and because of complete subshell, it will be more stable. So what will happen here? The ionization enthalpy will increase. Clear? So the ionization enthalpy of magnesium will be greater than that of ionization enthalpy of aluminium. So this will come in place of aluminium will come in place of magnesium. This is one exception. The another exception comes in a case of a phosphorus and a sulfur. What happens in case of a phosphorus and a sulfur? See, phosphorus will come in place of a sulfur will come in a place of a phosphorus. Why it happens? Because see, phosphorus here, atomic number 15, this is 1s2, 2s2, 2p6, 3s2, 3p3. This is half filled subshell. While when it comes to sulfur atomic number 16, it is 1s2, 2s2, 2p6, 3s2, 3p4. 1s2, 2s2, 2p6, 3s2, 3p4. In this case here, how many number of electrons are there? Here it is having up a 4. So it is partially filled. Which is more stable? Again, half filled will be more stable. If half filled phosphorus is more stable, so it means it should have a more ionization enthalpy. That's why phosphorus will come in place of sulfur will come in place of phosphorus. The real order here will be sodium, then it comes aluminium, then it comes magnesium, sodium, aluminium, then magnesium, then silicon, then it comes sulfur, then it comes phosphorus, then it comes chlorine. This should be the correct order. Are you getting my point? Now we will see in a ionization enthalpy in a group. What happens in ionization enthalpy in a group? See, we know that moving down a group, what happens up here? So, shells increases. Shell increases, size increases. So what will happen up here in this case? Force of attraction decreases. So it's easy to take out electron. It's easy to take out electron. Now what happens when it's easy to take out electron? Here the ionization enthalpy will decrease. So moving down a group, ionization enthalpy will decrease. This is all about size, variation of a size in a group and a period, and the variation of a ionization enthalpy in a group and period. Okay. For this lecture, we'll hold up till this point. Okay. That's all for the day. Thank you.